Hello everybody. In this video we are going to look at the solutions to the college prep right-hand rule do right now 2. In the first problem we have a proton moving at a speed of 3.0 times 10 to the fourth meters per second entering a magnetic field of 0.55 Tesla. They want us to find the direction and the magnitude of the magnetic force acting on the proton. So let's take a look and see what we are given in the problem. We have a proton and we are given the charge of a proton, although that's something we should probably know by now. And I know the charge of a proton is 1.6 times 10 to the minus 19th coulombs. I'm given the velocity of the proton of 3.0 times 10 to the fourth meters per second. Given the magnitude of the magnetic field is 0.55 Tesla, and I'm being asked to find the force. Now remember, we use the math and the formulas to find the magnitude of our unknown quantity, and we use the right-hand rules to find the direction of our unknown quantity. So to find the force, or the magnitude of the force, I need to use F equals QVB. I'm already solved for my unknown, the force, so I don't need to do any rearranging. I just need to plug my known values for charge, velocity, and magnetic field into the equation. And when I do that, I get a magnitude of the force of 2.6 times 10 to the minus 5th Tesla. Now to use the right-hand rule to find the direction of the force. Now remember, because I'm doing this to a camera, I need to do the opposite and use my left hand instead of my right hand, because the camera acts as a mirror. But remember, these are the right-hand rules, and as long as we are dealing with positively charged particles, we are going to want to use our right hand. If we're using a negatively charged particle, we want to use our left hand, but we have a proton, so I'm going to use my left hand to represent what the right hand would do. So I know that my magnetic field is in the positive Z direction, and that is represented by these dots right here. And I know my velocity is in the downward direction. So remember, in my right-hand rule, my thumb represents the direction of the force, my fingers represent the direction of the velocity, and my palm represents the direction of the magnetic field. If there were an arrow sticking straight out of my palm, that would show the direction of the magnetic field. So I want my palm to be facing away from the screen or toward me, so it's coming out of the page, and my fingers to be oriented downward. So if I want to hold my hand like this, my palm is facing away from the screen. It's facing towards my face. So that's the positive Z direction. My fingers are oriented downward, and my thumb is oriented to the left, or in the negative X direction. So my force is in the negative X direction. The second problem gives us an electron which experiences a maximum downward force of 2.5 times 10 to the minus 12th newtons when it is moving at a speed of 2.1 times 10 to the 6 meters per second toward the east. They want to know what is the direction and the magnitude of the magnetic field. So we are given the force acting on the electron, which is 2.5 times 10 to the minus 12th newtons. We are given the velocity of the electron, 2.1 times 10 to the 6th meters per second. We are given the charge of an electron. Well, we aren't given it, but we know the charge of an electron is 1.60 times 10 to the minus 19th coulombs. And we are being asked to find the direction and the magnitude of the magnetic field. So we'll use the equation and the math to find the magnitude, and then use the right-hand rule to find the direction. So to find the magnitude of the magnetic field, we want to use F equals QVB. Solving that for the magnetic field will give me B is equal to F divided by Q times V. I plug my known values into the equation, and I am going to get a magnitude of 7.4 Tesla. Now let's take a look at the direction. I know that my force is oriented downward. It's a downward force, so my force is going downward, and I know that my velocity is to the east. So my velocity is to the east. Now, I am dealing with an electron here. So because I'm dealing with an electron, I want to use my left hand because it is a negatively charged particle. So I'm going to use my right hand to demonstrate what the left hand should do. My thumb represents the force, so that wants to be oriented downward. My fingers want to represent the velocity, so those need to be pointing toward the right, and my palm will show me the direction of the magnetic field. So if I move my hand so that my thumb faces downward and my fingers point to the right, I can see that my palm is facing into the screen. Right? If I have an arrow that's shooting straight out of my palm, going right into the screen, that shows me that I'm going into the screen or in the negative Z direction. So I know that my magnetic field is going to be in the negative Z direction or into the page.